Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to our second lesson on periodic properties. Last time, we talked about the general trends of elements within periods of the periodic table. We discussed the trends in atomic radius, ionization energy, electron affinity, electronegativity, and metallic character. We looked at some examples of these trends. In today's lesson, we will look at these same trends with regard to elements within groups of the periodic table. Within groups, each succeeding element has one more principal shell occupied by electrons. Therefore, the atomic radii in groups increase from top to bottom. For example, if we look at group 8, which is the very last group on the periodic table, the first element is helium. Helium atoms have one principal shell. As we move down that group, we come to neon and then argon. Neon has two principal shells and argon has three. Every element that comes next as we move down that group has one more principal shell in its constituent atoms. As we reviewed in our last lesson, ionization energy is the amount of energy that is required to remove the outermost electron in an isolated gaseous atom or ion. The closer and strongly bound electrons are to the nucleus of an atom, the more difficult it is to remove them. Thus, when electrons are closer and strongly bound to the nucleus, the ionization energy increases. The first ionization energy is the amount of energy that is needed to remove one electron from the parent atom. The second ionization energy is the amount of energy needed to remove a second valence electron from the univalent ion to form the divalent ion. It is always greater than the first ionization energy. Further ionization energies continue to increase. Thus, moving down a group on the periodic table, ionization energy decreases as the atomic radii increase. However, all group 1 elements have low ionization energies. This is because the loss of an electron in the atoms of these elements forms a stable octet. Students, as we discussed in the last lesson, atoms that have a stronger effective nuclear charge have greater electron affinity. We can also make some generalizations about electron affinity based on certain groups in the periodic table. For example, Group 2A elements, which are also referred to as alkaline earth elements, have very low electron affinity. This is because these elements are stable due to having filled s subshells. Group 8, or the noble gases, have electron affinities that are near zero. This is because their atoms have stable octets. They do not require electrons to be filled. Students, which group do you think has the highest electron affinity and why?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. You were correct to say that the halogens, group 7 elements, have the highest electron affinity. This is because the addition of an electron to these elements results in a completely filled shell. Well done, everyone. Let us now discuss the trend of electronegativity in groups of the periodic table. Atoms of elements that are located in the upper right side of the periodic table attract bonding electrons more strongly than those of other elements. These small, non-metal atoms have the greatest electronegativities. Atoms of the elements on the left side of the periodic table, which are large metal atoms, possess a weaker hold on electrons. Thus, they have the smallest electronegativities. Within groups on the periodic table, electronegativity decreases when we move from the top to the bottom. For example, chlorine is less electronegative than fluorine, and sulfur is less electronegative than oxygen. If we are considering the electronegativity of elements that are neither in the same group nor in the same period, the comparison becomes less straightforward. Finally, the last trend we are going to discuss with regard to groups within the periodic table is metallic character. Metallic character refers to the chemical properties associated with elements classified as metals. Moving down a group on the periodic table, the metallic character of elements increases. This is because, as you move down a group, the attraction from the nucleus to the valence electrons decreases. Students, we have learned quite a bit about the trends associated with groups on the periodic table. In a moment, you will see several sentences that relate to what we have been learning. Please determine whether each sentence is true or false.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again, students. Were you able to determine which sentences are true and which are false? Sentence A is false. It should read, moving down a group on the periodic table, ionization energy decreases as the atomic radii increases. Sentence B is also false. It should read, the atomic radii in groups increase from top to bottom. Sentence C is true. Moving down a group on the periodic table, the metallic character of elements increases. Sentence D is false. It should read, atoms of elements on the left side of the periodic table have the smallest electronegativities. In today's lesson, we learned about general trends in periodic properties within a group of the periodic table. This brings us to the end of our lesson. Until next time, thank you, teacher. Thank you, students.